Hi guys, it's Dr. Mitchell again, here to talk to you about how we can call void methods. So in this video, we're going to create and use some non-static void methods without any parameters to get our outcome. So what are we going to learn today? We're going to learn about how an object's behavior is going to refer to what the object can do. We will find out what procedural abstraction is and how it can be useful to design our programs. We'll look at what a method signature is, and we will follow through the execution of statements when we call a method. So, if you remember from before, we know that methods define those behaviors for an object. We can use those to represent behaviors for an object, and they consist of, when we write them, our method signature and then the set of instructions or the statements within the method to actually execute that behavior. We saw this before with my dog example, where I created a dog that had a method to bark. So then once I actually created a grace dog, or just a dog, an instance of a dog, and called the bark method, it then was able to do the bark behavior, which was to print out wolf. So procedural abstraction allows me to create methods to represent those different behaviors, and then after I define them, myself and another user doesn't have to worry about how that method actually works. They can just call it and use it as they want to. So let's say, for example, I want to create a letter to, or a program to write letters to my friends. Okay, we know that obviously a letter is going to start with a greeting, so I'm going to have a method to represent printing out a greeting. Then I will have a method to print out special message. So that way I have some kind of way to create a special message for each friend and call that as I want to. Of course, every letter has a closing, so I will have that be the same for every friend. And then I'll have a method to actually write the letter, which will call the other methods and piece them all together. So I print out my letter to my friend. So looking at this in Java, here I have my letter and all of the methods that I planned using procedural abstraction. I have my write letter method that's going to call the other methods to piece together my letter. I have my greeting method, my special message, my closing, and then my main method will create my instance of a letter object, and I'm going to call that friend letter. Then the next line in the main method says to call the write letter method for my friend letter, which once I do that, I end up now, the program goes looking for the write letter method, which finds it right up here, finds that in the method signature, and it realizes, okay, write letter is going to first line of code, it says to call greeting. So now I'm going to search through the program to find greeting. So it finds it right below it and calls the greeting method, which will print out my sentence, hi friend. It then will return back to the write letter method, the next line of code in the write letter method, which is then to call special message. So I'm going to find the special message method in my program, which prints out computer science is awesome. Then the sequence of execution returns back to the write letter method to the next line of code, which says to print special message again. So I go back to where special message is, and it ends up printing computer science is awesome again, since that's what it was defined to do. I return again back to the write letter method, and the next line of code says to call closing. So it then searches for that closing method, which states to print see you soon. So it prints that statement, returns back to write letter and realizes, okay, there's nothing else to do in write letter. So then it goes back to the main method, but there's nothing else to do in the main method. So the program then ends. So what should we take away from this? We now see how methods can represent different behaviors for my objects. We can see the benefit of using procedural abstraction to break down and write methods to represent behaviors without having to know what that method does after we've defined and created it. We can call it however much we want to, and anybody can use it without needing to know. We've looked at method signatures, and we've also looked at how a method call will interrupt the execution of statements and return back after that statement has executed. So thanks. I will see you guys again soon.